Start
Right?
that.
So this is a common base configuration, and we are going to see its input and output characteristics. This is a BJT which comprises of emitter, base and collector. Pass. Start. So this is emitter, this is base and this is collector. This is a NPN transistor. Emitter is of N type, base is of P type and collector is of N type again. As we know that input side should be forward biased and output side should be reverse biased. It means that emitter and base should be forward biased, collector and base should be reverse biased. This is a N type, so it should be connected to negative of the battery. Base is of P type, so it should be connected to positive of the battery. The second one should be the resistor. Soon after a supply, we should have a resistor, and this is the resistor. You can see that here it is already soldered. And the next, we should connect ammeter here. We should connect ammeter here and voltmeter here. And coming to this output side, this should be connected to channel 2 of the power supply. This is a reverse bias. This is N, so N should be connected to P here, so positive of the battery should be connected here. This is of P type, so the negative terminal should be connected here. And at the output side, we have to connect ammeter here and voltmeter here. Let us start with the input characteristics. Input characteristics mean that input current versus input voltage, and the condition is that we have to keep this output voltage as constant. Let us start with the connections. As I told that negative is connected here and positive is connected here. Connect the ammeter here and connect the voltmeter here, that is at collector and base. We have to keep this VCB constant at some voltage and connect it back to the input side at emitter and base, because input current versus input voltage at output voltage constant. The condition should be, before going to these two, the condition is that we have to keep this output voltage constant, and so is the reason we first have to connect the voltmeter here, keep that at some constant voltage and connect back that voltmeter at this two slots. So these two are connected to the channel 1 of the power supply. So by changing this supply voltage connected here, we have to take the readings of ammeter and voltmeter. Start it with 0.1. When the source voltage or supply voltage is 0.1, take the corresponding readings of the current in the ammeter, voltage in the voltmeter. Change it back to 0.2, take the corresponding readings. 0.3, corresponding readings. Till 1 volt, we have to take the readings of ammeter and voltmeter. That is emitter current here and VEB, voltage between emitter and base. You can see that the voltage gets constant at 0.6. Once the voltage at this junction, that is emitter and base junction, reaches to 0.6 or somewhere 0.7, you can see that this gets constant. There will be no increase further in the voltage at this emitter and base junction. You can see only increase in the current here. You can see only emitter current getting increased, but you can see only a constant voltage at the emitter base junction. So these are the input characteristics, and the conclusion from this is the voltage should get saturated at 0.6. There should be no increase in the voltage.
Yes. Output. Yes.
Coming to the output characteristics, it should be output current versus output voltage. The output current here is IC, that is the collector current, and the output voltage here is VCB, that is the voltage between collector and base. The condition for this is we have to keep this current, input current, constant. It should be output current versus output voltage at input current constant. This is the general formula for output characteristics. Here the input current is emitter current, output current is collector current, and the output voltage here is VCB, that is between collector and base. This is supply and this is also supply. These two are supply voltages. These two are different. There will be surely some drop in the voltage here because of the resistance connected here and the remaining elements in the circuit. Right, coming to the operation or working, we have to first keep this emitter current constant. Let me say at IE equal to 2 milliamps. Get back the ammeter here and connect at this point, and connect the voltmeter here at this point. Two slots given there, right? And these two are connected to the channel 2 of the power supply. Keep on increasing this power supply and note the corresponding readings in ammeter and voltmeter here connected here, right? So you can see this. The conclusion from this is you'll see that the current whatever you get in this ammeter, which is a collector current, will not exceed than the emitter current given here, because the formula is IE is equal to IC plus IB. IB is almost a small, a very negligible, so IE is almost equal to IC. Let me say if you have given 4 milliamps here, the output, the final output here should be 4 milliamps. It should not exceed that. It should get nearly 4.1 or 4.2, nothing more than that. Okay, so this must be the conclusion from the output characteristics. Okay, you can see the current gets constant here, right? It will not exceed than the input current. So input current here is, to the circuit input current is IE and the output current is IC. So IC will be almost equal to IE. If IE is 4, IC will almost be equal to 4. If IE is 2, it will be almost equal to 2. This is about the output characteristics.